Alright, today we're going to talk about average rate of change, and I just want to welcome you back to Algebra 1. When I talk about average rate of change, I'm talking about old school slope, good old slope, that you learned in Algebra 1. And this is going to lead us into what a derivative really is in the next two lessons. If you remember, when we talk about slope, a lot of times some of us learn the change in y over change in x. The little triangle means delta. That's where that whole dy dx comes in, where d for delta. So that's where the idea of the dy dx comes in when you see that in calculus. It's change in y over change in x, or delta y over delta x. Some of you might have learned if I just take y2 minus y1 over x2 minus x1, in this case represented as f of b minus f of a over b minus a. Some of you may have talked about the idea of a secant line in geometry, and let me just be really clear what a secant line is. If I have a graph with a curve, we'll just do that kind of curve, parabola. A secant line just means it hits it twice, here and here. It just means the line went through the curve twice. That's all secant line means. Later on we're going to talk about a term called the tangent line, and that just means it hits it only one time. Just once. And so those are the, just for terminology, just to remember, secant line means it hits twice, tangent line means it hits one time. Alright, let's look at a couple examples. Number one, in an experiment of a population of bacteria, find the average rate of change from P to Q and draw in the secant line. Well, let's kind of get our points here. P is at 2350. Q is at 4530, and once again I'm drawing that secant line. Remember, it hits it twice. Let's see if I can draw a straight line here. Oops, nope, not going where I want it. Close enough. And so as you notice, it'll be hitting it twice, once at P, the other time at Q. And so there's my two points. And so again, we're just going to do just simple old school slope. That's not what I want to do. And so P is located at 23,150. Q is located at 45,340. And now we can just do y2 minus y1 over x2 minus x1. So I'm going to choose 340 as my y2. So 340 minus 150 divided by 45 minus 23. Well, that's going to be, let's see, 340 minus 150, that's 190. 45 minus 23 is 22. So if I reduce that, that's going to be 95 over 11. Divided by 2 on top and bottom. And so now we need to answer the question in terms of the problem. So if you notice, I have number of bacteria on the y-axis and number of days on the x-axis. So the average rate of change, that's what AVOR is, average rate of change. Whoops. Be nice if I actually put a C into an R. Average rate of change is going to be of the bacteria is 95 over 11 bacteria organisms per day. Alright, let's head over to number 2. An equation to model a free fall of a ball dropped from 30 feet high is f of x is equal to 30 minus 16x squared. What is the average rate of change for the first 3 minutes? And make sure we state units. So let's go ahead and get our f of 0 and our f of 3. So f of 0 is going to be 30. F of 3 is going to be 30 minus 16 times 3 squared is 9. Alright, and that's going to be equal to 30 minus, that'll be 144. Which is going to be equal to 114. Negative 114. So now let's do our old school slope. So I have negative 114 minus 30 divided by 3 minus 0. And that's going to be, that'll give me, let's see, negative 144 divided by 3, which is negative, let's see here, that'd be negative 48. And so let's answer in terms of the question. We're talking about feet, that's the units, and it's decreasing, so because it's falling. We're talking about minutes by others. So the average rate of change of the ball falling is 48 feet per minute. Alright, number 3, use the table below to estimate f prime of 1870. So before I get into what this is, I said prime, and you're like, what? So let's talk about this guy right here, highlighting him. So you have f prime. What that means is the slope around that point. Up to this point, we'll get into a better idea what that is in a couple units, but the way you say that is f prime. F prime. And essentially means what is the slope at that point. Yeah, if I was going to draw a tangent line there, what would the slope of that tangent line be? Again, remember, tangent line is that it hits this point and this point only once. Okay. Let me clear all that out. So I want to estimate the slope around 1870, or the average rate of change. Well, I have to be kind of careful because I can't use 1870. It's located right here. I have to use, if I want to estimate, I have to use the x and y coordinates that are around 1870. So we're talking about, do that a little bit better, 1860 and 1880. And so we want to estimate around 1870. So let's go ahead and get our y2 and y1. So I have, let's see here, 50.2 minus 31.4 divided by 1880 minus 1860. Well, that is equal to, let's see here, I think it's going to be 18.8 divided by 20, which is 0.94. So what we're talking about is 0.94 million per year. So now they want us to interpret the meaning of the value found in part A. So this was part A. Part B. So we're talking about the average rate of change, or rate of increase, we'll say that, increase in population is 0.94 million per year. Alright, well that just kind of sums up our average rate of change. Please kind of keep the idea of slope with you because we're going to be talking about slope pretty much through December. Welcome to the first part of calculus.